So, what we studied in the last class is the fragmentation, how a IP datagram that comes from the transport layer at the sender side is fragmented into multiple fragments depending on the size of the network or the outgoing path in which it has to travel. That is what is your fragmentation. And we took an example of a size of a datagram of size 4000 bytes, and we studied how it was fragmented to multiple fragments of starting address starting from 0 to 3999. Now, today we will see if the datagram is fragmented, what are the different fields that gets affected and how the values are, some of the values or some of the fields are copied into the fragments in the subsequent time. So, if this is the case, when this is fragmented into 3 fields as we discussed, if the M2 of the outgoing path is 1400, then we saw that you had one fragment here of length 1400 bytes. The next fragment was the another field or the another datagram having again 1400 bytes, and the last one is again another fragment having size of 1200 size. So, how the header fields of the fragment or these subsequent datagrams are affected? If you remember, the first word of your datagram is, it contains the value, the version field, then you had the HLAN field and you had a TLAN field, right. So, in this case the total length, what will be the, for this fragment, if this is the D1 datagram, this is D11, this is D12, this is D13, what will be the total length of the D11 field? For this datagram, what will be the total length? This 4000 is divided into 3 fragments, 1400, 1400 and 1200. So, what will be the total length for this one? Is that true? This field remains same, HLAN remains same because it is not going to add any other extra HLAN, whatever extra HLAN is here will be copied here. Then you have the total length. Now, the total length is, instead of this was 4000 in the original datagram and now it has become 1400 in this, and next you had the 3 fields, the ID field. The ID field will be, if the ID of this datagram is let us say XXX, then the same ID has to be copied in all its datagrams. Then flag, we will see what the flag is. In this case, what is the flag? If we consider the original datagram, the flag will be, forget the unused part, D will be 0 because it has been fragmented, and 1 will be, here 1 will be 0. Is there any more fragment here? So, now when it comes here in the fragment field, in the flag field, forget the first one, what will be the D field? This will be 0, could be fragmented whenever required, and the M field will be 1, mentioning that this is not the last fragment, there are few more fragments exist. And then you have the fragmentation offset field. What is the offset for this fragment? It is 000 or I mean 0. So, I say this is 0, right. Rest of the fields remains unaffected. So, we do not bother for that. So, what are the fields really affected in the fragmentation is the total length field, the ID as it is copied, and the D and the M field of the flag and the offset field. Similarly, for the next one will be total length will be your 1400, then the other field will be ID will be XXX, then this will be 0 and 1 followed by, what is the offset here? It was 175 probably. And for the same last one, what is the TLAN? 1200, then your ID field remains XXX, then this is D field is 0, M field, D field is 0, M field is 0, and this is again 350, right. So, these are the values or these are the fields in the header field gets affected when you have the multiple fragments in this. And similarly, as we discussed, if this gets fragmented further, you can find out what will be the values of the fragments. Only thing the T length will be changed and the rest of the things will be as it is. As it is means as required, 0 or more if it is it's 1 and the next one will be 1 followed by 175 some value, depending on the size the value will be there. So, this is how the information in the header field is changed during the journey of the datagram from its source till the destination. And when it comes to the destination, all the datagrams are collected by the receiver like D11, D12, D13 and again D12 has the datagrams like D121 and D122. So, with all these bigger and the smaller fragments of the data, when it comes to the reassembly unit or the receiver side, it finds the M field finding when M is becomes 0 and it finds the offset field till it gets the maximum, the last value of the offset. When these two combination becomes compatible to say that this is the last fragment that has been received, then the receiver starts reassembling the units or the fragments to come back to or to bring back the original datagram. Now, let us say in the whole journey, the first source when it generates the datagram, it says that my M field, D field is set to 1. This is the D field set to 1. This is the source datagram. What happens to this datagram when it goes to a router which is connected to a smaller network? MTU is less than the MTU of the source. What happens here? The packet cannot be fragmented by the router, it will be simply dropped. The reason is that it says it cannot be fragmented. So, whatever may be the case, if it says it cannot be fragmented, D field is set to 1, this is not fragmented by the router and the other parts are taken care of accordingly. So, this is what is the header information that tells the in between or the intermediate hops of the routers what to do and what not to do during the journey of the packet from the source to the destination. Now, if we say this is the IP or the internet protocol, what are its components? Who helps us to reassemble the datagrams or fragment the datagrams or to find a route to the destination? What are the different components of this IP? What we say is IP design. How the internet protocol is designed, because this is a protocol oriented model. So, for every protocol we must know how a protocol works and what is the design specification of the protocol. So, coming to the IP design or the IP components, we can say consider the sender side or let us say any upper layer. Upper layer means it is the transport layer. Now, in the transport layer what happens? Your data along with the header enters into the IP layer or the network layer. This is the network layer of the system. So, when it comes here at this stage, this usually we say these are the segments, or let us say again the data I will say. This data contains all the previous headers again, we do not mind for that. So, data and the header. So, the whole thing becomes now the packet or the datagram. Now, this packet enters into a block called the processing unit. It enters into the processing unit. Considering this as a sender side, assuming this is as a sender side, what the processing unit does? The processing unit sends the packet to a module called the routing module. What is the job of the routing module? It is like a box where the routing algorithm is executed, right. So, here your routing algorithm gets executed with the help of a smaller unit or a module called the routing table. We know that every host has got its own routing table. So, this module has got its associated routing table who says for this destination who is my next hop. let us say for the destination x, next hop is 1. So, this information is collected from the routing table by the routing module, or by executing this routing algorithm, this is found that it has to my next hop is 1, any router or any intermediate node whose number is 1. So, that means the datagram or the packet has to go to the next hop 1. Now, to go to 1, what the packet will do now, the sender or this routing module sends the packet to another module called the fragmentation module. Again, this module has got an associated with another table called the MTU. This MTU says which are the outgoing paths for this router or for this host and what is the MTU of that path. Let us say 1 is the next hop who is connected to this node, and the MTU of this node is something, let us say 1000. So, for every node or every route that is connected to this host has a definite MTU, and that is stored in the MTU table, and this MTU table gives the information to the fragmentation module saying that the packet to which you are going to send in this path or this route has the MTU of this one. So, accordingly the fragmentation module prepares the fragments. So, now your fragmentations are generated if the MTU is found to be less than the current one. If more, there is nothing to be done, simply they are sent to the DLL. DLL for what? Your frames are generated here, and you know all the path frames generated, then it goes to the receiver end. So, this happens for always the sender side as well as for any intermediate node. The same is true for either the sender or the intermediate node. Intermediate node could be any hop, any router or any node even. Now, let us say when it comes, it goes to the receiver, the final destination or the receiver arrives. Assume that here is the receiver, it comes to the receiver again now. Now, consider this as a receiver. When it comes to the receiver end, the processing module of the receiver, what it does? It sends the packet to a module called Reassembly Module. This is called the Reassembly Module. And this Reassembly Module is associated with another table called the Reassembly Table. It's called the Reassembly Table. And this Reassembly Table maintains all the informations of the datagrams that it has received. All the information or the fields that we study, starting from the ID, then the offset and the M field or D field, whatever is required. So, when all the fragments are stored in the reassembly table and it finds that M is equal to 0 of the same ID and the offset has come as per the total length of the original data, then it sends the information to the reassembly module to build up the datagram or the final datagram combining all the fragments from the reassembly table, and then it is sent to the upper layer, that is the transport layer of the receiver. So, the simple story is that at the sender side, the transport layer sends the data to the network layer or the IP layer. It adds its header information, builds the whole datagram. Now, this datagram goes to the processing module. Processing module sends it to the routing module to decide the path through which it has to be forwarded. When the path is decided, then the MTU of that path is checked. Depending on the MTU of that path, whether a fragmentation has to take place or not will be decided. So, the fragmentation is done or not done, whatever is depending on the size of or MTU of the outgoing path, and it is sent to the next layer, that is the DLL, for the generation of the frames. And frames goes in its path, reaches to the receiver side. Receiver side again it goes to from the DLL, it decapsulates the datagram and decapsulates the frame, and the datagram is delivered to the upper layer, that is the IP layer. the IP layer what it does then? Sends to the reassembly processing module, sends to the reassembly module. Reassembly module stores all the data information in the reassembly table till it finds m is equal to 0. When m is equal to 0, then all the fragments are brought back from the reassembly table, again reassembled at the reassembly unit and sent back to the upper layer of the receiver, that is the transport layer. This is how the IP datagram with all its components like the routing module, the reassembly module, the fragmentation module works together for fragmenting the data, reassembling the data and delivering to the corresponding layer for the transmission of the data. And during fragmentation how the header information is changed and how they are being checked by the receiver, that is different. One more thing, the checksum field, if you remember the checksum field. The checksum field, the original decides its checksum as per the 4000 bytes, right. But when the size changes with 1400 or 1800 or 12 or 1200 whatever may be, accordingly the checksum is also calculated, recalculated and that is also updated depending on the number of bytes stored in the particular fragmentation. So, another field that gets affected or that gets updated is the checksum field in the fragments, right. This is how your IP is designed along with all its components and the header is information is updated depending on the requirement.